If the Earth eventually becomes uninhabitable, we might have to turn to other planets. It's not an unrealistic option. We've already developed concepts and ideas for building habitats and even cities off-world. What will it take to get there? What would these planetary bases look like and be made of? From life on Mars to lunar civilizations, these are the designs that could one day let us live in space. Living on Mars. If we were to head to space to try and build a civilization, our most likely option would be life on the Red Planet. Humans have been exploring Mars for more than 50 years. In 1971, the Mariner 9 spacecraft orbited the planet and mapped out 85% of its surface. We first successfully deployed a rover on the planet in 1997. Earth and Mars are closest to each other every 26 months or so. Elon Musk suggests that every 26 months, for a 30-day period, we could send 100 ships to Mars, transporting around 100,000 people to the planet. If we could do that, where would they live? Concepts for habitats on Mars have been designed using many different materials and techniques. Mars colonization by ZA architects is an idea to create an underground network of caverns that could be inhabited by people. The caverns would be carved into Mars' rocky surface. Nuwa by Abibu Studio also proposes carving into Mars, but with a focus on its cliffs. They want to create a self-sufficient vertical city that would use the cliffs as natural protection against the Martian atmosphere. There's also Ice House by Clouds AO and SeaArc, which proposes 3D printing components using existing material on Mars to create an ice dwelling that could protect humans from radiation, thanks to ice's ability to filter out and deflect the sun's rays. Another interesting material that could be used is fungus. Mars Utopia by Idea Architecture Office proposes combining native Martian materials with mycelium and fungus, which are able to withstand extreme climates. They could create a protective layer, making hospitable habitats a possibility on the planet's surface. Then there's Mars Habitat by Lava Hive, which proposes a cutting-edge building technique called lava casting, which would use discarded materials from space vessels to 3D print a habitat. There's also a very down-to-earth idea that just might work. Martian Seed of Life by Warith Zaki and Amir Amzar actually proposes using bamboo as the building material. Bamboo could be grown on Mars thanks to an abundance of carbon dioxide in the atmosphere. Bamboo has the ability to withstand extreme conditions, which could make it a great protective material for human habitats. To experiment with and protect these ideas, tests are being done here on Earth, simulating conditions on Mars. Mars Science City is a project created by a team of engineers that simulates Martian conditions, allowing us to test different building strategies. Then there's the Virtual Mars City, which simulates a habitat for 100 people. The self-sufficient simulated city is a starting point for the creation of a life-size model on Earth, and hopefully an eventual structure on Mars. Out of all the proposals, there are a few techniques that seem to be the most popular. One of them is glass domes. Glass domes here on Earth can withstand harsh weather conditions, such as strong winds. They are used by astronomers and scientists to observe the sky. The ability to observe natural views makes them ideal for structures on a new planet, since they'd allow us to study the planet inside the confines of a protective environment. Glass domes are also how Elon Musk envisions us one day living on Mars. Through his company SpaceX, he hopes to build a habitat on the planet by 2050, with room for 1 million people. To get there, the company will use their Starship. The fully reusable ship is 400 feet tall, including its booster, and designed to send about 100 people to space at once. The ship could act as an initial habitat when reaching Mars, so that a more permanent glass dome habitat could be built. Musk believes that the first crewed mission to Mars could be launched as soon as 2026. Musk has suggested that the total cost of developing his Martian city is somewhere between $100 billion and $10 trillion. It's no easy task, but could you picture luminescent glass domes on the red planet that could be seen from Earth? Another popular technique for space construction is 3D printing. A few of the habitats we mentioned earlier were designed to have their components 3D printed using various materials suitable for life on Mars. One such project is Marcia. This egg-shaped habitat was designed by New York-based architecture firm AI Space Factory. One of Marcia's benefits is that it could be built by robots with little human intervention. Another benefit is that it's designed to be built from materials originating on Mars. In total, Marcia has 4 levels of skylight at the top, which allows natural light to penetrate all floors. On the ground level, there's a garage and wet lab where astronauts can work. There's also a prep station where they can prepare to explore the planet's surface. The second floor features communal space such as a kitchen and dry lab, while the third floor has a garden, sanitation pod, and personal spaces. Lastly, the fourth floor offers communal recreation and exercise areas. If it all works out for scientists living in Marcia, these egg-shaped habitats could one day make up an entire colony on the red planet, living on the moon. But before we get to Mars, perhaps we can test our techniques for living off Earth with someplace a little closer to home, the moon. Soviets and Americans have been contemplating lunar bases since the beginning of the space age. Project Horizon was developed by the US in the late 1950s in an effort to construct a scientific and military base on the moon. There's also the Moon Village Initiative, an open settlement that would allow any participants to join, including state and private companies. The village would be made up of a series of connecting mound-like structures. But how exactly will we build a base on the moon? There are a few ideas. First, we figure out where to build. It's possible that we could erect structures on one of the lunar poles. The South Pole in particular is considered the center of lunar operations for the USA, China, and Europe. The polar craters contain deposits of water ice, which could provide drinking water, oxygen, and rocket fuel components. One of the most ideal craters here is the 20-kilometer or 12-mile Shackleton. In terms of the North Pole, the most interesting crater is Peary, which also contains water ice. The 4 mountainous regions on its edge are illuminated by the sun for almost the entirety of a lunar day. They'd be excellent for solar power stations. The polar locations also offer stable temperatures in the permanently shaded areas, protecting settlements from sharp temperature fluctuations. Another potential building location is in a lava tube. These tubes pass under the lunar surface and are capable of sheltering habitats from meteorites, radiation, and drastic temperature changes. How could we provide energy for these bases? Solar energy would be impossible in most places at night because nights on the moon are equivalent to about 14 Earth days. Solar panels could therefore only function where there is eternal light at the moon's poles. Compact nuclear reactors could be useful. NASA already has a project in the works for a power plant that could work in space. It's called CRUSTY, which stands for Kilopower Reactor Using Stirling Technology. It uses enriched uranium-235 and converts heat into electricity using a Stirling engine on a sodium coolant. We could also equip lunar bases with alkaline fuel cells. They would produce electricity due to a chemical reaction involving hydrogen and pure oxygen. Last but not least, what materials could we use to make a lunar base possible? One of the most interesting possibilities is the use of inflatable modules. The beam compartment has been operated by the International Space Station for a few years now. These modules are lightweight but provide a large internal volume. They're suitable for bases both on the lunar surface and inside lava tubes. Or we use the ship itself, following SpaceX's strategy for Mars. This would give us time to construct habitats on the moon while still having a suitable place to call home. It's also possible that components of the ship could be repurposed as pieces of the lunar settlement, which would cut down on the amount of cargo we need to bring. Or we use the moon itself. Lunar soil could be used to 3D print bricks. This could give us material for construction and solve the problem of heat preservation within our bases. Experiments show that these bricks are able to accumulate energy and heat indoor spaces. However, these projects don't come cheap. NASA thinks it will cost between $20 billion and $30 billion to put humans back on the moon by 2024, with an additional $28 billion to $52 billion spent on constructing lunar bases. Do you think we'll have livable buildings on Mars or the moon in our lifetime? Let us know in the comments. Don't forget to like, subscribe, and hit that bell for more super cool construction concepts. Thanks for watching.